And welcome back. I'm sorry I couldn't be with you guys, but I have Quiz Bowl today. So you're going to learn about the distance formula, okay? So how do you find the distance between two places? Like if you're going on a trip or whatever, how do you do that, okay? So we can actually use the Pythagorean theorem to find the distance between 2 points. So I'm going to call this point A and this point B, okay? Now if I look at this, I can make a triangle like I've been doing the last couple days here. So if I look at this, if I go like this, and then like this, I have a right triangle, right? So I should be able to find this length, right? That distance, that's what I'm trying to find. So I know this is 1, 2, 3, 4 units, right? And this is 1, 2, 3 units. So I can sit here, and this is obviously C, right, because it is across from the 90-degree angle, so it is the hypotenuse. So I'm going to have 4 squared plus 3 squared equals C squared. And I'm going to solve it like I've been doing the last couple days. So 16 plus 9 equals C squared. 16 plus 9 is 25. Take the square root of both sides, because that's how we cancel C and C squared. So I get C equals 5. Okay. So there's what's called the distance formula, which we can find using the Pythagorean theorem, okay? So I'm going to do one more that's similar to this, and then we're going to actually learn the distance formula, okay? So again, I have this one here. It's slightly different than the last one, but same idea. So again, I'm going to make a right triangle, okay? And again, I'm going to solve for C, because that one I can't count very easily, right? Because it's on a diagonal, and that's kind of fussy. But I can count this really easy. 1, 2, 3, 4. 1, 2, 3, 4, 5. Okay? So again, I'm just going to do, again, these are the legs of my triangle, right? Or the sides. So it's going to be 4 squared plus 5 squared equals C squared. So 16 plus 25 equals C squared. And what is 16 plus 25? 41. So as you notice, the square root of 41 is not going to be a pretty number, right? It's not a perfect number. So that's why we use the distance formula, because sometimes it's going to come out as a decimal. So when I square root both sides, I'm going to get C equals 6.4 something something something, but we'll round to the nearest tenth. Okay? So that's why we use the distance formula instead of trying to count units for the diagonal. Okay? Now if you notice here, the way we found each side, we found this side by subtracting the difference between the x's, right? So the 5 was the change in x's. And the 4 came from the change in y's. Okay? And that's actually what uses the distance formula. Okay? So the actual distance formula is D, which is your diagonal, okay? Or in what we've been calling it is C, or a hypotenuse, okay? Usually, okay? If you're given 2 points, you can find it with the distance formula. So instead of graphing them, we can actually plug it in. So it's x2 minus x1, so just the x's subtracted from each other. We square that number. Plus the change in y's, square that number. We add those two numbers together and square root it, which is exactly what we did here. The change in x, the change in y's, doesn't matter which one comes first. The change in y's was 4, the change in x's was 5. We squared them, we added them together, and then once we were done, we square rooted it. So this formula kind of puts it all together, okay? But this comes from the Pythagorean theorem. So this might be something note card worthy here, okay? Now, you're always going to be given 2 points, so if you would prefer to graph it and see the change in x and see the change in y, that is absolutely fine. But if you kind of want the shortcut way, you can do it this way, all right? So I gave you 3 points. Okay, I gave you that x is negative 4, 2, y is negative 1, negative 5, and z is 3, negative 1. And I asked you as the first one here is find the distance between x and y. So I'm just going to rewrite my points. Again, I'm just using them from above here. So x and y. Okay. And I'm going to label them to help myself out. I'm going to call this x1, this one y1, this one x2, this y2. Okay, I don't really care which one is x1 and which one's x2, as long as you label them together. Okay, and then I'm going to use this formula. So D is going to equal the square root of x2, which is -1, minus a -4 squared, okay, plus y2, which is -5, minus 2 squared. Okay, so I want to do everything in the parentheses first. Now notice this is really addition, right? Because a negative times a negative is positive. So -1 plus 4 is just a positive 3. So I have 3 squared plus -5 minus 2 is -7 squared. Okay, 3 squared is 9. -7 squared is going to be 49. Okay, I'm going to just move over to this part of my paper. So D is going to equal the square root of 9 plus 49, which is going to give me 58. And again, that's not going to be a pretty square root, right? Okay, it's going to be some sort of decimal. 7.62, we'll say. Okay, units, whatever units it is. Okay, again, not a huge pretty number, but we can do it. So literally, I can just subtract these two numbers and be like, oh, okay, that's positive or -3, depending on which one comes first. This is going to be positive or -7, depending on which one comes first. It doesn't matter if it's positive or negative because the square is always going to make it positive here in the end. So it really doesn't matter if it's positive or negative, okay? As long as you do the subtraction correctly, all right? So let's try this again. Go ahead and pause it right here if you need to catch up. So the next one asks you, with these same points that we looked at earlier in the thing, the distance between y and z. So again, I'm going to write those points down. Okay. So I'm going to label them x1, y1, x2, y2, and I'm going to plug them into my formula. D equals the square root of x2, and minus a -1 is adding 1, right? That way I can have one less step to do. I'm sorry, this should be y2. y2, -1, minus a -5, which is the same as +5 squared. Okay, so 3 plus 1 is 4 squared. -1 plus 5 is also 4 squared. So I get D equals 16 plus 16 with a square root over it. So I get D equals the square root of 32. And again, that's not a perfect square. We're going to get some sort of decimal. So this is approximately 5.66, we'll say. Okay. Now we're going to do this one more time. I'm going to hold this so that you guys can see what I'm doing. Again, same points, and I want to find the distance between x and z this time. Okay, so again, I'm going to rewrite them just so I can see myself here. Ooh, that's a 3. Sorry, guys. And I'm going to call this one x1, y1, x2, y2. And I'm going to plug and check. And I'm actually going to plug and check over here so I have some more room. So I'm going to have 3 minus a -4, which is the same as +4 squared, plus the change in y, so -1 minus 2 squared. I'm going to extend my square root sign there. And this should be D equals, or whatever letter you're calling it. So I get D equals the square root of 3 plus 4 is 7 squared. -1 minus 2 is going to be -3 squared. Okay. Again, remember, any negative number that's inside of that, you're going to square it. It's going to come out positive. So I'm going to get 49 plus 9. Okay. So I'm going to get D equals, I believe we did the same thing here. We already did this one earlier. Okay. So this one's going to be the square root of 58, and we already know that the square root of 58 is 7.62. So the distance between x and z is actually the same distance between x and y. Okay, so that's kind of interesting, right? So if you were to actually plot those points, you can kind of see that. Your homework today is page 28, 1 and 2. There's a couple different parts, okay? But all you're using is the distance formula, okay? So you're plugging and checking. So just be very careful on what you're doing here. Please show it step by step. Take your time, okay? If you guys have questions, feel free to ask me when I am back on Thursday or email me. Have a great day. Bye.